Good morning, everyone, and welcome to our April 6th brunch and learn. Today we will be going over our residential quick guide with Brent Ursenbach. We are live streamed, so again, please make sure all your phones are on silent, and if you have any questions, please raise your hand so we can get you the microphone. We would like to thank the Utah of Energy Development, Thermwise, and Rocky Mountain Power for being able to offer this program for you guys today for free. We do have a couple of events coming up in May. We have another brunch and learn that we'll be doing, and we have a field training that we will be doing on duct sealing for residential. So if you have any questions about that, please catch me on the side, or you will be seeing emails go out regarding that. So I'll give it to Brent. Thank you, guys.
Thank you. Good to be here, and it's good to see a good crowd here. I don't know how many of you are aware, but we have been on the same energy code, residential energy code, for 6 years now. We're still on the 2015 energy code. The legislature this past session did adopt the 2021 I codes. This includes the building code, the plumbing code, the mechanical code, fuel gas code, and the commercial IECC, or Energy Conservation Code. And there's multiple sides to why this has occurred, but we have the home builders that feel that the cost of complying with the energy code is going to, limit the number of people that can afford to buy a house. We have people on the other side that say that we should build the very most efficient home that we can. I'm kind of the opinion we should be somewhere in the middle where we make sure we provide a fairly efficient home, not the latest and greatest technology, but meet a minimum code. Well, our minimum code nationally is now going on 3 code cycles ahead of where we are right now, because our 2015 code is actually amended code that includes a component of the 2006 energy code, some of the 2009, some of the 2012, and some of the 2015, and a little tiny piece of the 18. What that means is it's kind of difficult for all of us. If you're a builder, if you're a code official, we have a challenge because we have this kind of moving target. So for 6 years, I've been teaching basically the same code. And this last year or so, when we started talking about the 2021 code adoption, several of my good friends said, Brent, I don't even care if we adopt a new code. And guess why he said that? Because we're not enforcing the old one. We're not complying with the old one. And so my focus this year, and hopefully for the next 3 years, or 2 years, or whatever it takes before we consider code adoption again, is that we can get consistency on residential energy code enforcement and compliance. I shouldn't even use the word enforcement. Let's just use the word compliance, because compliance includes everybody, the builders, the architects, everybody kind of working together as a team rather than we're battling each other. And quite honestly, I think it's frustrating for all of us. It is for me. I get a call almost every day with some crazy idea that someone, whether it's a jurisdiction or a builder or an architect's come up with on the energy code. For example, I got a call about 2 weeks ago, and I think a lot of you are familiar with the code without amendments requires blower door testing on every home. We have an amendment in Utah that you have an option to blower door test, or you do this comprehensive inspection. Well, if you test tighter than 3 air changes per hour, 3 air changes per hour or tighter, the code requires mechanical ventilation. We have to have an exhaust fan. I got word that a jurisdiction, when someone tests tighter than 3, doesn't say, well, you need to buy a Panasonic or some other fan, put it in for mechanical ventilation. Your house is tight enough that we need to ventilate it. Guess what their solution was in that jurisdiction? Cut a hole into the house so that it leaks enough that it doesn't hit 3. So anyway, we have some challenges. We have some challenges. I'm not trying to pick sides. I understand everybody's side. By the way of introduction, my name is Brent Ursenbach. I should have done this first. Most of you know me. My career started in 1972 when I was 20, so you can do the math. And I worked in HVAC for 33 years. Then I was a code official, and I did that for about 13 years. And then in 2018, 5 years ago, I retired from that. And I do this, and I do some expert witness stuff. And one of these days, I might really retire, but we'll believe it when we see it, huh? But I have a passion for this. As an HVAC contractor, I'd like to see, and my boss, when I first started in it, and then when I was in business, I like to build a system that really worked, and Ryan knows what I'm talking about. I always did load calculations. I always did duct designs so that my systems worked, so that they lasted 20 and 30 years because the airflow was right, and all these things. I knew what the envelope was doing, so when I became a code official, it was just kind of a natural thing to move into energy, because what does energy look at? The very same stuff that Ryan looks at when he does a load. The thermal envelope, the air leakage, everything else. So that's been my life for 51 years now. One last thing before we move into the slides. I am available. I work under a contract with Jacqueline, with the Office of Energy Development. I am available as a resource. I'm going to ask, and you've heard me say this, I'm going to ask you to please send me an email if you got a question first, because I do not work every day. So, if you call me, I'm either doing this or I'm playing, so I'm not going to answer my phone probably if you're not in my contacts. So just send me an email, or if it's an emergency, send me a text and say, hey, this is John. Do you have time for a question? Can you give me a call? Maybe tell me what it is. So anyway, and I'm happy to do that. I love this stuff. I think it's great. Jacqueline mentioned this. We're able to do this. You got a free breakfast. You get to listen to me blab for 3 hours or so for free. Do this group, Dominion, Rocky Mountain Power, and the Utah Office of Energy Development. So what is our issue? Our issue is, and one of my friends, who's a HERS rater, sent these pictures to me. And he had gone out and done testing. Okay. He goes out and he does, you know what a HERS rater is? They go out and they do testing and everything on a home. And he goes out and he sent me these pictures. These are brand new homes that fail miserably to comply with the energy code. Why do they fail miserably? Is it the architect's fault? Is it the jurisdiction's fault? Or the general or the sub? The suppliers? Doppel? Contractors, we're all there. The homeowner? Everybody has a little bit of a piece of responsibility in this. The homeowner has the least responsibility because most of them, sure, large custom homes, they're involved, and they're usually, I've done thousands of custom homes, large custom homes, and those people weren't the ones that wanted to build a cheaper home, and cut corners. They wanted to do it right. But I really think that the top three all bear responsibility. And we did a class on this. We talked about the architects in their AIA statements say that they have a responsibility there at the front. They need to know the codes. They need to do this. Jurisdictions. I worked for a jurisdiction for 13 years, so I know what it's like. They're busy or they're not busy, or they have political pressure. There's a whole bunch of stuff. We have unique people, just like we do in every other, business or anything else, we have inspectors that want to work with you. We have inspectors that don't want to work with you. We have some that get hung up on little things. We have some that just let it slide. We have many that say, oh, energy code isn't life safety, so I'm not going to worry about it. Well, the code is more than life safety. It's also general welfare. And the cost of energy is doing nothing but going up. And so we need to address that. So anyway, without going too much more into that, everybody has a responsibility. My goal is that we bring those top three together and we try to get on the same page. We try to be consistent. And so with this class, and I don't have one anymore. Well, here's one. Notice this says first draft. I reached out to about a dozen people and asked them what they wanted to see on a checklist that could be used for plan review and inspection. And I had some say, I want a long sheet that has, you just go down the line, and then others said we wanted a little bit more compact. So anyway, this is my first stab. I am looking to all of you to give me input. I found this morning that I left something off that's important already. So I know something needs to be done to this. I want to, in the next 2 or 3 months, I want to have a document that's useful to everybody. It's useful to the architects, it's useful to the contractors, it's useful to the jurisdictions, helping us get on the same page. This document, in conjunction with this document that has been out in one form or another for 6 years, really summarize what's going on with the residential energy code. So what I am doing is asking for your help in creating a functioning guide that everybody can follow, that makes sense. Obviously, we can't put so much information on it that it gets too big and cumbersome. We want it to flow fairly good and not have too much detail. We're going to assume that people have come to some classes, have studied, and know a little bit about it. So there's my goal. I need to just take a minute and talk about a DOE study, and some of you have heard this because I've shared a few of these slides before. Over 4 years ago, the Office of Energy Development asked me to participate with them in a DOE study that was done in Utah and Arizona to identify how compliant our residential homes are with the energy code. And so we just got started on it a year or so into it, and you know what happened, right? COVID hit, and so we kind of, for 2 years, it kind of just crept along real slow, but finally we've got through it. So really what we had was this team, Institute for Market Transformation out of Washington, D.C., managed it. We had, a field team, we had advisory team, we had myself, and we had Rocky Mountain Power Dominion, Department of Energy. We had all these groups supporting. And the goal was to collect data from the field across 2 states and just kind of determine where we were at. And from that to develop targeted education programs to address those measures that needed the most attention or would result in the greatest savings. And so what happened was HERS raters basically went out and checked a bunch of homes. Now the data might be a little bit skewed because they had access to homes that people wanted to have HERS ratings done on them. And so some of the homes are homes that we're trying to build, a little bit better. It's better than the first study that took place that jurisdictions volunteered to participate, and only jurisdictions that were enforcing the code volunteered. And I was one of them, and guess what? We just took those that were studying to homes that we knew were good homes. We're not going to go show our dirty laundry to everybody, are we? So anyway, neither study's perfect. This one's closer. These are the things they looked at. They didn't look at everything. I highlighted envelope tightness because actually we're building homes tighter than we think. And we'll talk a little bit more in a minute on that. Look at windows, look at wall insulation, ceiling insulation, lighting, foundation insulation, and duct tightness. That's just, it was random sampling, and there's all the places that they looked at them. I don't think we need to spend time on that. And so here's the potential savings that they suggested was exterior walls would result in the greatest savings. Why would exterior walls be the greatest savings in Utah? Anybody know? It's because we have a Utah 2012 res check that I think some of you are familiar with. And what does the Utah 2012 res check allow us to do? It allows us to trade off high efficiency furnace and air conditioner, windows, and allows us to put in a crappy wall. We can build a house today with 2x4s and put R11 insulation in the walls, and if we use the Utah 2012 res check, we can get it to pass. We can get it to comply with the code because we're putting in a 96% efficient furnace. We're getting savings there. The problem is, how do you fix the walls? That wall's a piece of crap forever, right? Well, not necessarily, but it's expensive to fix, isn't it?
Well, we remodel all the time.
Yeah, you remodel, and you can fix that. I have a house built in '92 that I stripped siding off and put 1.5 inches of polyiso on it. Made a big difference. But that's costs a lot more money to do that than it would to build it with 2x6 and put better insulation, or put the foam on it when I built the house. You know, and we can, you know, we can discuss that for the rest of the time, but we're not going to. But in Utah, that's, our walls are weak compared to the code requirement because they're looking at the actual code, not the amended Utah code. And that's a big savings annually. The thing that I said, should this concern us, our envelope tightness was pretty tight. We were tighter than expected. So if our envelope's tighter than expected, how should that concern us? It concerns us because we're not ventilating them. We're not blower door testing everything. If we don't blower, well, there's a lot to it, and I'll talk a little bit more about that. But let's just say the amendments lessen the chance there's going to be mechanical ventilation, simply by the way they're written. So we're building a lot of houses that are tight, that no one knows they're tight. We're not mechanically ventilating them, so we're trapping moisture in the houses. We're trapping contaminants in the house. We have poor air quality. And I don't think after what we went through the last few years that we really want poor air quality inside. I think we want better air quality inside, don't we? Duct leakage is a big one too. So key takeaways was that we need to focus. Well, number one, they did not measure HVAC systems or ventilation efficiencies and a few other things. Now, I kind of wish they would have looked at the HVAC more, but it's a little harder to measure and judge how well that HVAC system is performing. It takes a lot more testing and everything. Exterior walls and duct leakage are responsible for 70% of the total savings, the potential savings. Windows are getting better. You know, when we first started getting serious about the energy code back in 2007, 8, 9, windows were not that great. We had lots of just clear double pane vinyl glass on the market, and low E glass was a premium. I built a house in '94, and I paid a big premium to put low E glass in that house. Move forward from the early 2007, 2008 to now, if you notice the windows you put in today that you just buy, the standard AMSCO or whatever window, instead of running 3.4, 3.5, is running what? 3.0, 3.1. And that makes a big difference when you drop the U factor that much. And so just window technology has, it's not because we all did a great job in what we're doing, it's because window technology has improved. And no one even, if you went to a window supplier and said, I want clear glass, I don't want low E, they're probably gonna charge you more because they have to change production. And those things are fairly good. Air leakage is low, like I said. Attics are generally close. And basement walls slightly fail to comply. We're just running off the screen just a little bit. So I've just talked about we all need to do our part. Here's a little graph of air leakage. Here's 3.5 air changes per hour at 50 pascals. And this is where all these homes fell. Most of the homes fell tighter than 3.5. The code without amendment, if we were on the 2015 code without amendments, it would say you have to mechanically ventilate at, anybody know what number? The trigger for mechanical ventilation in the 2015 code is 5 air changes per hour. As soon as you go tighter than 5, you have to mechanically ventilate. Our state amendment dropped it down and kind of stepped it down, and we're now at 3.5 is what we have to meet if you blower door test, but the trigger's at 3. So we don't have to mechanically ventilate until we hit 3 or lower. Well, look at a good portion is flirting with that 3 number, and then a bunch is tighter than 3. How many of those do you think have mechanical ventilation? Don't know. We have, the code itself has 4 options to comply with the code. I kind of like the energy code because it doesn't say you have to do this. It says you can do this or this or this or this. And in Utah, we have a 5th one down at the bottom, and that's that Utah 2012 res check, which allows us to put in that high efficiency furnace, which everybody's kind of doing anyway, aren't they? Ryan,
They are kind of doing that, but there is a problem.
hang on a sec. She's going to give you a microphone so everybody can hear.
There's a lot of people doing that. There is a problem with that, though, that jurisdictions are facing now, and that is the SEER rating and the HSPF rating has changed as of January 1st. That does not have any way to do the SEER 2. So on the heating side, I think that's still gonna be, can still be used, but on the cooling side or the heat pump side, which there's a lot of going to heat pumps, that's going to stop that, that trade-off.
Yeah, you make a great point, Ryan. And I don't know how many are aware of that, but they've changed how they rate the SEER, the SEER rating thing. And yeah, the Utah 2012 res check doesn't address that. And guess what? DOE, we had to beg DOE to make the 2012 res check, the Utah res check, so we'll be okay if it won't go any further. Oh, that's beautiful. As Jacqueline crawls across the floor. You know what? We don't even, I've told this to those that are still supporting it, we don't need it anymore because we have the energy rating index. The energy rating index will let you trade off virtually anything. You can trade off more than any other thing, way better than ResCheck, way better than the simulated performance. It lets you trade off you can get trade-offs on your refrigerator, isn't that right, Jeff?
Yeah, you can take back your appliances off.
All your appliances, you can get credit for them.
Lighting.
So What's happened with the ERI path is you can, in fact, I'll talk just a minute about that. You can trade off a lot of stuff. In fact, in southern Utah, people with money have a big view that they paid $1 million for a view of Red Rock, like to build a home that has a wall of budded glass. And you know what budded glass is? It's half-inch panes of glass, solid glass, that they just butt them together. You just have a little line that they seal, and so you have a wall that's pretty much frameless, just a little line every 4 feet or something like that. What's the performance of half-inch solid glass? It sucks. It's horrible. However, if they want to build that house, they don't have to go to the mayor and put political pressure on him, so he puts it on the code official to approve his house. They can use the ERI path and put in the great refrigerator and all this other stuff and go overboard on HVAC and everything, and they can get that to comply if they have one wall that's just terrible. So the ERI path gives us the most flexibility of all, and it gives you a score. So we'll talk a little bit more about that. But yeah, you're right, Ryan. And I mean, we're virtually on a 20-year-old code almost in some of this. So I'm going to real quick, and why I'm doing this, and I'm going to grab Jeff's again. If you look at the checklist that I put together, the first thing on it is, for the most part, is which option are we selecting? And so before we went to that sheet, I wanted to review these a little bit so they were in your mind when we got to the sheet. So real quick again, prescriptive, which just means you meet a table. Res check, it's a UA trade-off. Simulated performance, it's an energy model. You have the home you're going to build, you have a standard reference design home. You compare the two, and if you calculate that the home you're going to build has energy consumption equal to your standard reference or less, you comply with the code. But you don't get to trade off a lot of stuff, do you, Jeff? No. And then the ERI, which was new in 2015, you get credit for virtually everything in your house. We're looking at the whole thing as an assembly, not just the envelope, not just the HVAC. We're looking at everything. And then we have down below that 2012 res check. So just a little more background. The equipment trade-off was in the 2006 Energy Code. You could take that equipment trade-off, and it was in previous MEC checks before res check. You could always trade off for higher efficiency furnaces and air conditioners. That was in the 2006. In the 2009 IECC, it disappeared. All those that were involved in the code development process agreed that we have one chance to build a wall right. Let's build the wall right. We're not going to give an equipment trade-off anymore. And so it disappeared in the 2009 code. So what did we do in Utah? Nothing.
They DOE'd it, right? Well, they did it for free.
We did nothing. We did not adopt the 2009. When the 12 came around, I'm trying to come up with the right word. Let's just say the legislature said, okay, we'll adopt the 2012 with all these amendments if you can get a res check that gives us an equipment trade-off. I mean, that's what it said. It'll go into effect 6 months after a Utah res check, specifically for Utah, for the amendments, is developed. And so we went to DOE, and we said, we want to adopt the 2012, we're on the 2006, and DOE wrote for us and like 6 other states, new res checks that met this convoluted set of amendments to the code. And that's what, when 2015 came along, we stayed with that 2012 res check. If you notice down there, we did some stepping on it. So when we first adopted, and it was 2014 by the time we got it, you just had to pass. The legislature did put in that you had to pass by 3% starting 2017, you had to pass by 4% starting 2019, and you had to pass by 5% starting in 2021. That's where we're still at. So if you use the 2012 res check, and it prints out as the Utah Energy Conservation Code, you have to pass by 5%. Now, I ran probably between 50 and 100 res checks where I would run it with the Utah 2012 res check, and then I would run it with the 2015 res check. And the number really should be closer to 10% to have some type of equality. So what I'm saying is if you use the 2012 res check, you're building a home that's about 5% less efficient than if you use one of these other. Now, if we compared it to the 2021, we're probably, I know we're more than that. You know, we're probably 10% less efficient than if we were on a more current code. It's what we have, you know, that's what we can, that's what we're dealing with. And my goal is that at least we're all across the state complying with one of these. Everybody's asking, everybody's designing based on one of these, all their plans include a compliance option. Any questions? So let's just real quick, we'll go through each one of these and we'll talk about what each one of them is. So as I said, we have 5 compliance options in Utah. The first one's a prescriptive table, and I'm sure most of you are familiar with that, but if not, that's fine too. That's why you're here. It's simply a table. And if you're in climate zone 3, which is Washington County, St. George area, you just have to meet everything that's there. And so it's a 0.35 window, a 0.5 U factor on a skylight, solar heat gain coefficient of 0.25 or lower, 38 in the attic, R20 in a cavity or 13 in a cavity, and 5 continuous insulation on the outside of a wall. And St. George actually meets that quite a bit because they do EFIS systems where they put foam on the outside. If they put enough foam to get R5, then they actually build a pretty good wall. Mass walls will skip over, hardly applies. And a basement wall in climate zone 3, either R5 continuous or 13 in a cavity, and the same for a crawl space wall. And then we have similar numbers for climate zone 5, which is where we are, and climate zone 6. But if you notice, climate zone 5 requires more insulation, climate zone 6 even a little bit more, especially in walls. So if you pick your climate zone and you build your house and it meets those values, you comply. The numbers in the 18 code and the 21 code are better than these. And so here we are, we're skipping and not adopting, and so the code is getting better, homes would be more efficient, and we're staying back here on this table. Res check, I think a lot of you are familiar with res check. Here's a res check done to the 2015 IECC, which is that option. And you simply have to pass. If you use the 2015 res check, you simply have to pass. The simulated performance, that's that modeling that you do. You just have to show that your energy usage is going to be less than your standard reference. Now the ERI, how many are not familiar with the ERI? Good, thank you for being honest and candid. And I'll bet you there's more people that didn't raise their hand that are not that familiar with the ERI. It's an energy rating index. Now, when this was added to the code, they wrote up the criteria for this software, what it would have to do. And the only, that I'm aware of, the only system available at that time that they could use was a HERS rating, a home energy rating score. Is that right, Jeff? So it's a score. And so when I say ERI path, I'm really saying a HERS score. Because at this point, I think that's the only system we have to score a home. Now, why didn't they just put HERS in it? Because it's a private company that has developed this, and they're not gonna put that in there. I've heard word that there is another system out there that's very similar that's gonna be available, or maybe it's coming online. I don't know if you've heard anything.
Well, there's a different software. ResNet was the one that, or RemRate was the software company that did all the HERS scores at the time. Now Ecotrol does them, and then a lot of guys are switching over to that, in fact.
Yeah, so there is a second one. There's RemRate, right?
Yeah.
Which is the HERS score,
Yeah,
and Ecotrope, is that right?
yeah.
And it follows basically the code identified criteria. And so I think the scores should be relatively similar, shouldn't they? But the beauty of this, and I just love this one, there's so many advantages to this. You know, if I were to give them, I have a dream speech, it would be that every home in Utah had a HERS score or an ERI score. I mean, it would just, you know what? It would take all this arguing about the code and everything and kind of put it on the back burner, because why? Because if your home had a score, when you listed your home and you had a good score, you made extra money because of your home score. Let me explain how it works. So the HERS index takes a reference home with a score of 100, which is basically a 2006 IECC house. So you build a home in compliance with the 2006 IECC, just barely met the basic requirements, met the prescriptive table or whatever from 2006, you have a score of 100. You build a house that's 1% more efficient, you have a score of 99. You build a house 40% more efficient, you have a 60. You build a house that's 70% more efficient than that, you have a 30. Why did I bring up the number 30? Because 30 kind of is, and maybe you'll disagree a little bit, but generally my understanding is 30 is kind of the magic number. If you get down to 30, you can put a reasonable amount of PV on your house and become net zero. To put enough PV on your house with a score of 100 is going to be a whole bunch of PV. You're going to have to be putting it on columns, and your whole yard's going to be PV panels. That makes sense? So if your goal is more efficient, then you build a more efficient home, you have a lower number. Now think about that. If we had a score for every home, and many of you have bought a house before and you're looking at two different houses and you're trying to make the decision and they have very similar features. If one had a score of 70 and one had a score of 40, which house would you buy? The 40 that uses 30% less energy. If we had a score on everything, the market would drive efficiency. Now, they've been trying for 10 years in Congress, or 15 years in Congress, to push mortgage lenders to consider some type of allowance for utility expense. 2022 was the first time my property tax was higher than my utilities. Prior to 2022, my utility expense was higher, annually was higher than my property tax, which is saying my utility expense was the number 2 cost on my house, right? So I don't buy the argument, well, if we have to spend an extra $5,000 on our house to meet the energy code, some people aren't going to be able to afford a house. Well, if we build an inefficient house, they're not going to be able to afford the house they bought because no one looked at what the utility expense was going to be on their house. Right? People, when they get in financial trouble, one of the things they're always fighting with is their utility bills. And I'm sure many of us have lived there. One of my kids had a medical thing in their family that almost bankrupted them, and utilities were killing them. You know? So I don't have nothing but positive to say for this. My only complaint is, of course, those red numbers for our 3 climate zones means they were amended and raised up. So when this was adopted, the numbers for climate zone 5, I think, was 55 or 56, and it was raised 14% by the legislature. So you only had to have a 69 to pass. Any question on that? So if you choose this, you're building a house, you identify how you're going to build the house, the insulation, your mechanical system, your appliances, and you project what you're going to use. You have Jeff or someone else, a HERS rater, run you a projected rating, and you submit it with your plans. Then when the home is done, Jeff will be coming by. How many times would you go by?
For her rating?
Yeah, if you're doing a new home.
Well, if you're doing it for Energy Star, you have to do more time, but if you're just doing it for her rating, basically.
Hang on a sec, we're going to have you say it in the microphone.
For Energy Star, you're gonna be making more trips to the house doing inspections. You have to do insulation. You do have a lot of the same inspections that the municipalities do. But for, just to get a HERS score, it's not much more than you're doing for code now, which would be duct blast testing and blower door testing.
Okay,
So Energy Star's always required you to test all mechanical systems, whether in conditioned space or not,
right,
which is still a good idea, because we find a lot of leakage in quirky places.
sure,
I've got a few builders have me test them all anyway,
yeah,
especially after they suck all the insulation into the return side and fill up the coils on a system that was all inside conditioned space, so.
right, right. Very good, thanks, Jeff. Notice he said something interesting. I've had, as when I was working in Salt Lake County, I had people come in and say, we're going to do the performance approach. You don't have to worry about anything. We got it all taken care of. That's not true. If you're doing performance or the HERS score, you identify the insulation, the windows, and everything else. He's not going to be there every single inspection. You as code officials need to be there. But for you to be there and check for it, what do we have to have? And this is kind of my lead into one of my biggest soapbox issues. Whatever compliance method you choose, the R values, the U factors, the solar heat gain coefficients, all the thermal performance information needs to be on the plans. Do I need to say that again? Everybody get what I'm saying? We have a res check. You do a res check. You say the windows are going to be this, and the walls this, the attic this, and all that stuff. But the plans say something different. or they don't say anything at all. I see that more being the case more often than not. Rarely do I see everything consistent across all the construction documents. So we might have this beautiful plan, we've selected one of these options, and we're gonna comply, and we have a document that says we're gonna comply. We submitted this, or we submitted a res check, or we even said we're gonna comply with the prescriptive table. Well, if the plans don't match the prescriptive table, the insulator doesn't come and say, let me see your res check. He says, let me see your plans. And he looks at the plans, and the plans say R11, when your res check says R19. And they get out there on final inspection or whatever, and the windows are all screwed up. What do? You end up with a house that doesn't comply. And who gets screwed? The homeowner, right? The homeowner. You know, we do all this arguing among code officials and architects and other design professionals and builders and everything, and ultimately, the homeowner's the one that ends up paying for it down the road. I just want to see us build good homes for my grandkids and their kids. My kids already have their homes, but please, she's going to bring a microphone to you, okay?
When and how is this form generated? Is it generated before the plan review when you're declaring how you're complying? And who prints it, who generates it?
That's a great question. And I can't remember your name, but I didn't notice you there.
Jim Burdett.
That's right. I did some inspections for you many years ago. Good to see you. Question is, when's this form generated? This form needs to be generated for plan review. So before you submit for plan review, you need to have selected your HERS rater and got him involved. He will generate this projected rating, and it'll say projected rating based on plans, field confirmation required. All this ranting I just went through was to say, we need the plans to actually be based on this, because they are so often not. Does that answer? So this one comes before you submit, then this one at final.
So does that mean every plan has to go through a HERS rater if you're choosing this method, or can the architect verify that this is the intent?
Say that one more time so I can repeat it. Or wait a minute, she's got the mic right here. We got people online.
Before
Sorry.
a plan submittal, if you're going this method, does that mean you have to hire a professional HERS rater, or can the architect declare that can the architect generate this?
If you
Plan designer,
use HERS, you're going to have a HERS rater for every home.
okay.
Comment right here?
I was just gonna say, so for the second report, how does the HERS contractor, or whoever, does it, actually verify that stuff? Are they coming to each inspection to see these things as they're being installed? How are they gonna know what's in the walls?
They don't inspect insulation, right, Jeff?
Well, on a lot of her stuff we do, but a lot more detailed than what a building official would, because we have to actually grade the insulation for, like Energy Star.
If it's Energy Star, yeah, they come out, they grade the insulation, they make sure that it's installed correctly and everything. But the point I'm trying to make is the code official still has a responsibility, and that's why I want it on the plans. So when you go out, all you have to do is look at the plans. Someone's already decided, what the method is. You're looking at the plans, and if the walls and the windows and everything match the plans, it's nothing new.
So I guess I'm just saying, what is the benefit of having the second report? Because the first report's all we're gonna inspect you.
The second report is necessary to to verify not just insulation, but you're verifying, where's your testing information on there, Jeff?
Well, it says blower door there.
Right here? Yeah, blower door, right there. Part of this is a blower door test. If there's ducts in the attic, part of it's a duct test. Because those are all a piece of it. So they're verifying, and they're also verifying what fridge you put in and what everything else that you claimed when you generated that first report.
You also get a 45L tax credit.
And to get the tax credit we got back there. Raise your hand high.
So, reading on this code adoption that's going to happen in July for the IRC, there's a section in here talking about information on the construction documents, specifically pertaining to basically what you're saying. So, just to clarify, so everything that or maybe not everything, maybe you can clarify this, the information that we have on our manual J&Ds, the information that we have on our res check documents, all of that will also need to be on the plan sets themselves. It feels like that's how the code is reading, but I just wanted to clarify that.
I've read so many versions of what the legislature did, and I glanced through the thing that passed, and if I recall, instead of a big checklist, the state amendment says documentation required to obtain a permit, or something like that. Is that correct?
I think it depends on which code you're looking
Yeah.
at. This new adoption that we're looking at in July, from what I'm seeing here, it looks kind of like a checklist.
Well, maybe they have added a checklist.
It's got energy compliance path, and then it's got R values, U factors, all of that information on there. And it specifically says to be on the construction documents, so I felt like it kind of overlapped with what you were saying, and we just want to make sure that that's a code item that we're following.
Yeah. Yeah, I'm going to apologize that I've looked through that. That's a long document. And it changes every legislative session. And I really haven't spent too much time on it because we're not on it yet. Until we adopt, what the code we're on right now says is the checklist is crossed off and it's documents necessary for permit. And I guess I should focus more exactly on what that says. What I'm trying to focus on is how we build a house that's energy efficient. And I simply want to make sure that everything's consistent. I did a lot of jobs, and when I did commercial work, and those of you that do commercial work know that if you have this job that's been on the bid table, there's a set of plans, there's the spec books, and you have all this other stuff. And if you look real close, the plans don't match the specs. And the contractor and the subcontractor are responsible to catch all the errors and let the architect know, right? And if you don't catch it, it's your fault. You eat it, not the architect. And I'm not bashing architects. Well, maybe I am, but I did a lot of jobs that the plans sucked, the specs sucked, and it made the job hard to do. And I just would like to get everybody on the same page. If we're going to do prescriptive, let's make sure that the prescriptive table is simply on the plans, so it gets built that way. If we're going to do a res check, so many times that res check that is submitted has different U factors, different solar heat gain coefficients that are on the plans. And the legislature might change a little bit what can be on the plans or not. I kind of want us to just step up and let's try to build what we say we're going to build. And I'm just trying to simplify it a little bit with the checklist so that we get there. I'm glad there were some questions on this. This isn't used very often. are a few builders that are using it right now, and jurisdictions, if they submit this, don't make it really hard for them. Get a hold of me if you have some questions. We've had some disputes between them, and they weren't that difficult, but this was unfamiliar to the jurisdiction. In fact, there's jurisdictions out there still that say, you have to submit res check. The code doesn't say that. You do not have to submit a res check. You have 5 options. 2 of them are res checks. The other 3 are not res checks. You do not have to do a res check. You just need to identify what you're doing and make sure it's indicated so everybody can follow it.
Brett, I just want to add one thing that, this is kind of a new novel idea. Share this information with your suppliers and your trade subs.
Say that again.
It's kind of a new idea. Share this information with your suppliers and your trade subs, because a lot of times they have no idea what's is this, because the plans are very generic most times, and they're just putting in what they normally put in, and it doesn't meet this, and in the end, you don't end up what you're supposed to be building with, and it gets caught at final or something, and that's too late.
Yep. Do you know, you could really eliminate a lot of, and some of you've heard this, and I know it sounds like a broken record to you, we could eliminate a lot of confusion if, I mean, this, especially on commercial jobs, but the same on a residential. We have a plan, a residential plan, and it's gonna have a floor plan, it's gonna have a structural plan, might have a plumbing plan, might have electrical plan, might have a mechanical plan. How about we stick in a sheet or on the front notes page or whatever, we stick in a section that says energy. Do you know how much time you would save on plan review, especially on a large commercial job or a large custom home, if the plan examiner could go to the energy sheet and see everything there? Those of you that do plan review, especially commercial plan review, know what I mean, because you get out this big set of plan and you're looking, well, you're not flipping pages anymore, you're scrolling through pages, and you're looking for where did they put the wall insulation? And you go through 1,000 elevations and you go through all these different pages and you're trying to find a stupid R value for a wall. Just bring it together, put it on a page just like you do all the other stuff, or 2 pages or whatever it takes if it's big. And let's make the process go smooth. And then your subs have it and your general has it and everybody has it, you know. A well-organized plan simply makes it go smoother. We all know that. It just makes so much difference.
Isn't that more of an architect thing, though?
It is an architect thing.
Plans with cut and paste prescriptive code on energy tabs, and that's not how they're asking me to build it, that's not how they're asking me to bid it. And, you know, their energy page is basically cut and paste from the code tab.
Well, if their energy page is cut and paste from the code, it's okay as long as you don't have a detail like your elevations that show a different R value.
The other thing is you see detailed wall types with completely different R values as well.
That's my point. We need to have it consistent. You're never going to get it right if the res check says R19 in the wall and you go to the plans, and it might even say on it per res check, but the plan has R13 in the wall. We just want to get it right. You know, it's not that hard. We have so much technology now that makes it so much simpler. It's not like we have to redraw it by hand and everything else. It's so easy to change. And we're not printing all these plans and bringing them into the offices and then having them go back and then, you know, back and forth. I mean, I remember finishing plan reviews at the county on big projects. And so they would bring in the pages that were reprints. And so before you issue permits, what are you doing? You're pulling the staples out of this great big roll of plans. Will's over there shaking his head, right? And you're trying to shove in the right page because it has the clouds and it has the updates on it. It's great we do it electronically. When we're all done and everything's resolved, you print a set of plans. 2012 res check, I probably beat this one to death. we're making pretty good time though. Allows the equipment trade-off. And as I said, it's not anywhere near equal. And as we look at possibly adopting, there's a chance, and I don't know how big, I don't know if it's this or that the legislature will consider again the adopting the residential energy next year. So it'd be July of next year. Over here.
So with that res check, there's no minimums on any of the other like categories, I guess. Like how you were saying, down in St. George, they have like the big glass walls, so which are not efficient whatsoever. But there's no minimums on those.
That's a great question. When you run a res check, there are some minimums, and we got to be careful with the word minimum, but you're using a good word. With a U factor, smaller is better. With R values, bigger is better, but yeah, we're on the same page on that. There is on Windows, if you do res check, the U factor maximum is 0.48. You cannot model, or you cannot put a 0.52 window in on res check. It'll reject that. And there's a couple of things like that in there. There is some, res check doesn't have any limit on window area. You can have as much window as you want in res check. And the other thing is res check is just an envelope compliance tool. And so is the prescriptive table. You still have mandatory stuff with air sealing and everything you have to do. The others pick those up. So, yeah, there are some hard limits in there, but they're not very many. And there's little kind of unique pieces that I'm not even attempting to try to put on this page or this guide, but I'm trying to catch the major things, and so we get fairly consistent. Now you see this one says the compliance passes by 14.9%. That's a pretty good pass rate. It is the Utah Energy Conservation Code, which is the Utah 2012. But they put a lot in the attic, the walls are good, and they have good windows. They have 0.32 windows. The prescriptive table says 0.35. So their windows are pretty good. And they didn't even use the equipment trade-off. They're still passing by 14%. That just kind of points out that we're really behind with our code.
Where does it say if they use the trade-off or not?
I'm sorry?
You said they didn't use the equipment trade-off?
They did not use the equipment trade-off on this.
And where is that stated on there?
It says right here, compliance passes using UA. Okay? UA is the U factor times the area of that component. So if you have 40 square, well, let's look right here. We have windows, 40 square foot with 0.32 windows. You multiply them together and you're going to come up with around 13. And there's some rounding and stuff that takes place in there. They're not going to be exact all the time. But you take the U for the component times the area of that particular component, and that's the UA. And so what it's doing is it allows you to trade off. So if you have a weak component, you could end up with a high UA. If you have a strong component, you'll end up with a low UA. And we'll talk the difference between U and R in just a second. Please.
Brent, on your first line item, I've seen a couple res checks where it states cavity versus continuous. I've seen some res checks that say, okay, if the bottom chord's in our 2x6, we've got X amount of R value in the cavity, and then the rest of the attic blown is continuous. Was there specific guideline on that?
Absolutely. I heard a chuckle over here, right?
It's a sneaky way to get past a res check.
And it's wrong. In fact, it is so important that this little sheet that I prepared, if you look at the top of it, key definitions. I have R value, U factor, continuous insulation, and cavity insulation. I have, and then the other one, slab on grade insulation. I have 5 terms that I wanted to define. And the continuous insulation, and this is the definition now of the code. Insulation materials are assemblies continuous across the framing, penetrated by fasteners only. That's screws, nails, or pins. What this gentleman just brought up, and I've seen it, and I still see it, they come in and they say, okay, they do their res check, and res checks actually has flags that pop up on it. I have a set of trusses, 2x4, 2x6 bottom cord, doesn't really matter, but I'm blowing 12 inches in. And so they'll say the depth of the framing, the bottom cord, is cavity insulation, and then they're saying the balance of the insulation that runs over the top of the bottom cord of the truss is continuous. Is it penetrated by more than a fastener? It is, right? Those other members of the trusses penetrate it. And if you take out a thermal camera when it's cold in the attic or hot in the attic, you can actually see in the ceiling where those come down and connect to the bottom of the truss. You can see the heat transfer that occurs because it's penetrated with a framing member. And if you go to Res Check Help, there's a whole discussion on it. Insulation in any type of truss is cavity. It has to be continuous with only a fastener penetration. It's a great question. And I see it. I mean, I still have someone they'll send me a res check to take a look at, and I'll see on the attic, I'll see a continuous and a cavity value. You know, I don't even have the plans, but it's a red flag. I'll say, hey, how did they do this? Now, if it's a roof system, say it's a flat roof system in an apartment building, they could have a set of trusses and continuous on top of the deck, right? And then you would have both values. You're going to have a continuous value on top, and you're going to have a cavity value underneath. And that's great. But it's a great point. And a lot of it is they're just not familiar with ResCheck. ResCheck is really a kind of a handy program, and it's simple. I like ComCheck even more because ComCheck makes it excuse me, easier to show compliance. Because in a commercial building, we have the envelope, we have the mechanical, we have the lighting, we have the service water heating and all that stuff. And the ComCheck really helps bring it all together. But you know, I like ResCheck, but I love the ERI path, the HERS rating. I think it's the thing of the future, hopefully.
That even has some trade-offs there in the insulation. If you require R20, they're going R19. So that's
Yeah,
a bit of trade-off right
they have a
there.
little bit of trade-off. Do you know what? A little change in the U on a window makes a big difference. You go from a 0.35 to a 0.3 window, and it's huge. It makes a huge difference. I get a lot of calls from people say, I put all this insulation in the attic and it doesn't make any difference. Well, no kidding. Once you hit 38 in an attic, adding to it just doesn't make that much difference. It simply doesn't. You know, in fact, the 2021 code takes, I can't remember if it takes us to our 60 or I think it might. But anyway, once you hit, it's not that expensive to go from 38 to 49. but you really don't get very much. You just don't get that much.
It does give you a point or two on a res check.
A point or two, but it's not gonna give you 5 points. I had another thought on that I was gonna throw out. Oh, yeah. If you wanna make a difference in your attic, what do you need to do? High heel trusses. There's what makes the difference in your attic. R38 in the attic with a high heel truss where you have R38 going all the way to the plane of the outside of the wall makes a lot more difference than going from 38 to 49 in a conventional roof that you still only have this much insulation at the perimeter. And if it's a hip roof, you have that all the way around the whole house, right? Where you have trusses dying down on the wall all the way around. So, you could actually comply with the code in a lot of cases by just making some smart decisions. And ResCheck will allow you to put in high heel truss, and you'll get credit because you're able to get full depth insulation all the way around. And what else do? You minimize ice damming. I have 2 neighbors right now in just 8-year-old homes. They're dealing with ice dams with all the snow on the roof. There's this much insulation at the edge, so it melts there, runs down to the overhang, freezes, and they've got ice dams, and they've got water coming into their house because of a pretty simple thing. So this page, we developed the first one of these 6-7 years ago, and it's our quick guide. And I'll be very candid with you. I've suggested before, use this for your plan review. And I've had a lot of people say, oh, can you give me a list? Can you give me a checklist? And really, I build it off of this. And I think this is still a good reference, but what I'm going to suggest is you use this with this. And as those of you that are code geeks or energy geeks, or you just love this stuff, please spend some time on this and send me some suggestions on what you'd like to see on this. I already got a second edition on stuff I discovered this morning, because I missed 2 things on this that I wanted to have on it. But I'd love your input. I want to know if you want it more spread out, or, if it's cumbersome. It's difficult for me to know where you're at and where your experience is. There's nothing wrong with not having the same experiences as someone else. It's part of life. Every one of you have more experience in something than I do. Anyway, I value your input. So anyway, this is a guide that I've developed, and we updated it in 21 because we did have some things change with the legislature in 21. And you will notice red text. And generally in this document and in the other one, the checklist that I created that we just unveiled this morning, I used red text to identify something that has a state amendment. So I have put a lot of code sections in there. And if you go to the 2015 IRC and look it up, you're not going to know what the state amendment is. If you Google Utah Construction and Fire Codes Act, you'll find the state amendments. Or if you need to send me an email, I'll send you a PDF of it. And I don't know if it's been updated yet for the last legislative session. No? Ryan says no.
As of 2 weeks ago, one thing to help, there's nothing more frustrating than having 2 people come to it with a code book and somebody have the state amendments and somebody not. hopefully in about 3 weeks, the HBA will get everything worked out with ICC, where we will be printing a Utah code book as far as IRC. The amendments will already be in there. So that'll save, hopefully, a lot of confusion, too.
You made my day, Ryan. You absolutely made my day.
So
If that happens, I'll be,
Yeah, that's the plan. We'll get an update next week, but we're waiting for the state to finalize their draft, and then it'll go to ICC, and that's the commitment as they've given us, is there will be a Utah, just on IRC. We're not gonna do the other I codes. The other thing that the HBA is doing, is we'll be going through the energy code this year and proposing something for next year.
yeah. And that's
So-
that's what Tom told me,
Yep.
is that, but there's no guarantee it's gonna happen. I mean, that something will pass.
It's the legislature, of course it will. They're always out for it.
The Beatles wrote a song, and I'm just gonna say the name of the song, and I'm gonna leave it at that. And it's called The Fool on the Hill. You might know the song. And I have friends that are in the legislature. I even ran for the legislature once, in '88.
We need to change duct leakage, so.
Duct leakage needs to be fixed, and ventilation needs to be fixed.
We need to change that though, if you're under 1,000 square feet. You tested it before 1,000 square feet, just like Energy Star did years ago, because you get a 600 square foot upper area. That's it. So code official stuff down here that might have some push in the legislature, the duct leakage testing for Utah is far more difficult to meet than Energy Star. Because we're only allowed, if you have a small area and they've got bonus room press up, they put the little system up there, and maybe there's 600 square feet total, you're allowed to leak 36 CFM of leakage. You could probably seal off that mechanical furnace before you even install it, and probably gonna leak more than that. So Energy Star says if you're under 1,000 square feet, test as if it were 1,000 square feet. You'd be able to leak 60, and that's much easier to meet.
Okay, so what Jeff's saying is, and keep the mic in case. Blower door testing is based on volume. It is not based on exposed square footage, right?
Right.
So a big house has lots of volume. The ratio of volume to exposed square footage is advantageous to them versus the smaller
I'm talking
house.
specifically duct leakage testing right now, though.
Oh, you're talking duct
Yeah.
leakage.
So it's based on, per 100 square feet of floor, you can leak 6
Okay.
CFM. So you get a little area, bonus room area over a garage, for example, and they're good enough to put a separate unit up there, so it's actually gonna heat and cool. But that, if it's 600 square feet, they can only leak 36 CFM. And that's almost impossible to hit.
Can they hit it with AeroSeal?
Yeah, but, you're gonna spend a couple of grand to get that done, so, yeah.
Give me proposed language.
Um,
We'll get it in there.
Match
Su-
Energy Star, yeah.
su-
I talked to
suggest
Ross
it-
about this a few years ago, too,
Well,
over there, but,
get it, Ryan's
Yeah.
involved on the committee.
yeah. Okay.
I'm glad you brought that up, and I'm sorry I misunderstood you at first. There's two things. We have duct testing for testing of leakage in ducts. And I'm sorry, I don't have a lot of sympathy for crappy leaky ducts. And Ryan knows this. If you make some effort as you're putting it together, you can get a fairly tight duct system. Now, I brought up AeroSeal. Anybody familiar with AeroSeal? It's been recognized nationally as, as a pretty great, innovative method of sealing ducts. What they do is they spray an acrylic something polymer mist into the ducts under pressure, and it seals the holes. It seals it from inside. There is an ESR report from ICC approving it. There is a little bit of debate right now, and I don't know where it came, well, I know where it came from. It came from a guy at UL that says, well, it really doesn't meet what UL said, and I've reached out to him and he hasn't replied back to me, and I know him real well. I'm not gonna throw him under the bus in front of you all. But anyway, so it's creating some heartburn in the valley right now. And this is leading me to the point that I'm gonna say something to everybody here. Code officials, and I think Ryan can back me up on this, let's try to get on the same page. Let's be a little bit careful digging your heels in on something that's maybe not that big a deal. AeroSeal works. It seals ducts. It doesn't degrade. It doesn't fail. And digging in your heels and upsetting builders that are influential builders is going to end up with the code doing more of what it's done in the last little bit, and that's deleting the word approved out of the residential code. And what happens when we delete the word approved out of the residential code? Say it louder.
I said prices go up.
Means the building official loses his authority. The building official digs in his heels and makes it really difficult, and then the legislature says, all these places where, by definition, in the code where it says approved, it means the authority having jurisdiction, the building official. And we need to work together, and if we have a question, get a hold of me, get a hold of Ryan, get a hold of some of us, and let's try to work out a solution rather than have a builder that builds lots and lots of homes change the code because we messed them up. Someone using AeroSeal is doing what? They're spending extra money to make sure they have a good duct system. And then for us to say, no, you can't use it, is kind of counterproductive. I'm going to leave it at that.
Especially with Department of Energy is where it came from.
Yeah, it came from Department of Energy.
Department of Energy and Berkeley Labs is where it was.
It was developed by them. It's approved by ICC. And even if it isn't, I'm a firm believer in the alternate methods and materials in the code. The code can't cover everything. In fact, as a consultant, I've written some, in fact, I did one for Salt Lake City. I've written some interpretations on the code. In particular, one was a shipping company, that they had historical data that shows that their overhead doors are opened with the trailer backed into it 97% of the time. They had lots and lots of doors. I justified not insulating the doors because you weren't using the damn things for a door, right? You focus on the seals that seal the trailer to the opening. Why spend more than $1 million on insulated garage doors, overhead doors, for 2% or 1% of the time when the door's closed? What's the intent of the code? Where are we trying to go? I'm not saying give anything away. I'm trying to say let's come together and let's be reasonable. Sometime the building official needs to do some homework. Yep. And there's resources. I'm not the only guy out there. There's a lot of smart people out here, smarter than me, that can help you with some of those questions. In fact, we got a really smart guy coming in June. Construction Instructions coming back. Mark LaLiberte. How many have ever listened to Mark? Smarter than me, isn't he? Yep. He knows building science. He knows it really, really well.
It's like on this ductwork issue, that furnace you got up there is already way oversized on a small upstairs furnace system. So if it's leaking some air, it's not gonna cost that homeowner anything, and they're not gonna notice any difference in comfort up there either. If you're leaking a little extra air out of that thing, it's already oversized, it's gonna run at whatever it runs at.
Yeah.
It doesn't do anything. I've talked to building officials and said, and they say, yeah, just go ahead and pass it, so,
Yeah. Yeah, there needs to be some things adjusted,
yeah.
so it's reasonable. But I love the questions, I really do, because we're answering those, those questions you have. I can't believe, did you have a question? Or are you just stretching? Yeah. I admire all you guys. You're the ones that have to sit there and listen to me. I can kind of move and everything. I wrote this code change. I took it to ICC, I put it in the code, and guess what I did? I left it off my checklist for today. So, what does this basically say? I'm just going to summarize real quick. For years and years and years, in fact, it goes back into the 80s. I remember Questar it was Questar at the time. They used to be really involved in our HVAC systems. Brian remembers this probably. In fact, I would do a system. I put in the gas line, we'd pump it up, test it and everything, we'd leave on a home. And Questar would come out and they would come in and disconnect the gas line from the furnace, and they would pump up the gas line and double check and make sure the gas line didn't leak. And then they'd set a meter. And if the furnace is installed and stuff, they would come in and they'd derate the furnace. Right, Ryan? Peen the orifices, derate the furnace. Take care of everything. They did an inspection for combustion air or whatever the case might be. And I still remember I was in a subdivision. I'd done like 8 homes over on 13th East and about 47th South. And they came in and they said, and I think this is like early 80s, I don't know. And they said, you have to put combustion air in everything now. 2 of them. High and low, and if it's horizontal, it has to be big enough your dog and cat can go through it at the same time, right? My house built in '92 had 2 10-inch combustion air pipes coming in from outside for an 80,000 furnace and a 40,000 BTU water heater. But the whole point is, they said we're building too tight. That's when the term unusually tight construction was in the code and defined in the code. We're building too tight, and so we have to cut a hole in the wall, basically, so we have some combustion air. And some jurisdictions at that point did what I thought they should have done, and what we finally did in the 2015 code is if you have natural draft appliances, so a water heater with a diverter, a furnace, an 80% furnace that isn't sealed, either one of those in your home, bringing combustion air in from outside, you have to enclose them in a room, create a separate environment for them so that we're not leaking all that combustion air into the house. And I don't know how, you could never get a house to pass a blower door test with 2 open 10-inch pipes.
You might be able to on some, a lot of these mechanical rooms now, they're not sealed.
Oh, I know they're not sealed.
They've got some visqueen on the wall, but it stops 6 inches short of the top plates, and then all the joist cavity openings are wide open.
Yep.
Ductwork's okay. So that's 8-inch vent or whatever they got coming in there.
It's
Holes-
still,
all the holes around it are offset, and then they still got a gasket and door there and everything. Doesn't make any difference.
it doesn't make any difference because they're not doing it right. They're not doing it right. Why do you think I put this in the code? Sure, it was that, but what was my real purpose of putting it in the code?
Backdrafting.
For the exceptions. I personally think that having, if we required, and if you as builders made sure the furnace room was sealed and went to the effort of sealing the furnace room and insulating it properly and putting the proper threshold and everything, making sure the room was sealed, you'd say, oh my hell, this is ridiculous. Let's just put in a direct vent furnace and a direct vent water heater and not have to worry about it. That was my goal. And it's still my goal that we just put direct vent appliances in. And don't tell me that, oh, direct vents have more problems, because I had more problems with 80% furnaces than I did 90% furnaces. I never cleaned flame rods on 90% furnaces that were drawing combustion air from outside. If you're drawn from inside, you are going to be cleaning flame rods. Am I wrong, Ryan? then I'm correct. If some of you has an 80% furnace and you know what you have to do, you go down and take the little rod out and polish it up with a Scotch-Brite or something, put it back in, and your furnace runs fine, it's because it's getting contaminated with the crap you generate in the house.
Especially laundry.
Laundry stuff, detergents and dryer stuff, fabric softeners. Just make it direct vent. Guess what? If you put in a direct vent furnace and a direct vent water heater, and you put in a 700 CFM range, and we adopted a current code, you don't have to put makeup air in for your range hood. The whole reason we have makeup air for a range hood at 400 CFM or greater is because you backdraft the B vent, and it's dangerous. If you put in direct vent appliances, you don't have to deal with that. Now, your range hood's not gonna work real well unless you crack a window or something, if it's a big one. But, you know, combustion safety is paramount.
Plus there's rebates.
Plus, there's rebates. And while I'm on it, I'm gonna jump on the next soapbox. Builders, HVAC people, please, please run the second pipe. If it's a direct vent, install it direct vent. Install the combustion air pipe coming in. Don't draw from inside. Climate zones. How late are we supposed to go? We might finish early. Anybody gonna care if we finish early? Yeah. Climate zones. This is for code officials, but it's also for architects, it's for builders, it's for everybody. And notice I didn't ask architects to raise their hand. There might be some out there. That's okay. There's some great architects in Utah, by the way. Climate zones in the 2021 code change. Up in, is it box elder and, it's box elder, carbon, and was Cache one of them? Or did Cache stay climate zone 6? Anyway, three counties moved from climate zone 6 to climate zone 5 because historic weather data shows they're a little warmer than they were before. And so they changed. Hasn't changed for us because we're still on this code. Now, I worked for Salt Lake County. I worked for Salt Lake City for a little bit, but then Salt Lake County. And we did a job, this building. We inspected this building. Anybody know where that building is? Top of Snowbird. You probably went out there, didn't you, Mark? Or were you not working there then? It's 11,000 feet. What climate zone is it? What climate zone should it be? 7. In fact, the Utah County line is that way, and is it Summit? Yeah, Summit County, within a couple of hundred yards of that building.
It's the same as Sandy, that climate zone right there.
Same as right here. It's our climate zone. It's Salt Lake County. Now, should we change it back to how the climate zones, the 17 climate zones or whatever it was in the 2003 code? No, because it was so cumbersome. No one enforced the code because it literally changed with the street, you know what I mean? It's based on heating degree days and cooling degree days is where your climate zone is. And so the majority of the construction in climate zone, in Salt Lake County is in climate zone 5. So as a code official, I could never say, well, look at it, dummy, it's 11,000 feet, it's climate zone 7, you have to build to climate zone 7. I can't do that, and I shouldn't do that. I should only enforce what the code says. But I can certainly recommend, you know, design is minus 13 or minus 17 or something at this location, not 10. You should consider building a little bit more efficient building because of the environment that it's in. And they did. We didn't have to tell them. They'd already done that. And this was designed by a great architect and mechanical contractor and everything. It has a bunch of glass and it complied with the code. But just making the point. And we're not the only one. It's not just Salt Lake County. It happens down here in southern Utah and some of those places where we go up, and we're in Washington County, but we still have some higher altitude and we have some colder temperatures, and it happens in others. It probably happens I know it happens in Utah County that goes up to Thistle or whatever. So let's just use common sense. I threw in the slab-on-grade floor details because that's something that we still need to talk about a little bit. If you build slab-on-grade, ResCheck, DOE ResCheck admits that their software was flawed for a number of years. They tried to fix it at the code hearing so that they could trade off slab edge insulation. It's never gained traction, and so I think it was about 1.5 years, 2 years ago, ResCheck was updated so it matches what the code says. And the code does not allow you to trade off slab edge insulation in a UA calculation. What I'm saying is, if you build slab on grade, you have to put slab edge insulation in, unless you do an ERI, a HERS rating. You can trade it off with the HERS, but you have to put in slab edge insulation. And I guarantee you 80% or 90% of the jurisdictions are not making you do it right now. I'm not trying to point fingers because I don't think everybody's aware of it. But you cannot build without slab edge insulation, and you, the builders, look at those details and you're going, oh my hell, how am I supposed to do that? It's a tough one. Slab edge insulation is a tough one to do, but it's one that works. Ryan knows because he tries to make houses comfortable that are slab on grade, and if you don't have slab edge insulation, you're never going to have a comfortable floor, ever.
I don't care what you do.
It doesn't matter. You don't have the ability in your heating system to address that because the floor, concrete under the floor is always cold. Back in the 70s, when I was working for Bonneville Heating, there was a guy named Jay Page, Discovery Homes, and out in West Jordan, he built a bunch of nice little ramblers. You know, 2 and 3 bedroom ramblers, and he put that bonus room behind the garage. You know, 2 or 3 steps down and a slab that was 6 inches up from the garage, this nice family room. Beautiful plan. Very popular plan. We were doing the HVAC for those, and we got complaints that it's always cold in there. And so they started blocking out in the foundation. We ran underground duct, and we'd run a perimeter loop all the way around that family room, bring it back. We had return down there. We did everything we could, and it was still always cold in the family room. And this is open to the rest of the house. We even tried putting the thermostat down there in the family room, and guess what it did? We started having limit problems with our furnaces because the furnace would run trying to make the family room warm. The rest of the house was so hot, they were closing all the registers. And what happens when you close all the registers, Ryan? Furnace hits limit, right? So we were there one time, and I took the HVAC guys that carry around the little thermometer that they can shove in the duct. I took it over to the carpet and worked it down and kind of worked it underneath the carpet pad. It was cold. Guess what the temperature was under the carpet pad? 37 degrees. Is concrete a good insulator?
It's like you need better carpet pad.
Yeah, they need that. Well, I guess you could do that. Slab edge insulation works in cold climates. and it's the only thing that works. And it has to go to top of slab for it to work. I see it all the time. They come up to the bottom of the floor and they go in. They'll go in 4, 6, or 8 feet, but you still have a path from the slab into the foundation wall to outside. And unless we break that, it's never going to be comfortable. And it's going to consume energy, but I'm more concerned about the comfort.
Doesn't take that big a break.
Guess what we did back in the 70s? Concrete expansion. That's all we put in. There wasn't a code that made us do anything. We had them put in a piece of concrete expansion to give a thermal break between the stem wall and the floor. And we raised this floor temperature like, I think it was 34 degrees or something like that. It was still a little cool. It's going to be cool because it's only 55, 60 underneath the floor, but we were close to that temperature.
So is that still acceptable, these expansions now?
Actually, the question is expansion still acceptable? I have allowed, and I base it on what the code says. The code will allow you to, where you're coming up on the inside, it'll allow you to chamfer the insulation to bevel it at a 45. And so you virtually have no insulation at the very top. And then if it's 2-inch insulation, 2 inches down, you have your R10. The code will allow it. I don't think the performance, well, I did a little calculation, just a rough one, and that performs slightly better than a piece of 1/2-inch expansion, but it's not that much difference. We know how much difference a thermal break made in aluminum windows when they first put it in aluminum windows, you know. And so the expansion, it's like I think it's like an R.7 or something like that. It gives us the break, and it makes a big difference. And so I have allowed that.
The pushback you get from the builders is if they keep their 2-inch to the edge of slab like that, then they're gonna have to recess their stem wall back 2 inches because there's no place to put their carpet tag.
And they're exactly right. It's a difficult detail. I mean, I built a house in '94, the one that I paid a premium for low E. And I had a walkout basement, but I had brick and 2x6. And so by the time you did the brick, airspace, and 2x6, drywall, and baseboard, we hid we had enough thickness that we hid the top of it. But otherwise you don't. I have seen builders take and cast in the top of the stem wall a pressure treated 2x6 and then come up to the bottom of the floor with their foam, and so you have R1.5, for that 2x6. And if it's sticking out into the room a little bit, the carpet layers love it. It's a little detail. Does it cost a lot more? I don't think that much. Please, right here, Jack.
Now, I've never built a house where we haven't doweled rebar from the outside concrete foundation to the inside, and that doesn't even address it,
No.
unless you put the insulation on the outside.
Well, and I've seen, I appreciate the question. And I done the same thing on that one. I had the rebar doweled into it, and when I built it, I simply just notched around the rebar. Is it perfect? No.
Yeah, but the rebar acts like an accelerator for the temperature. It will draw it into the slab.
It will. But the rebar, our value of concrete isn't that much better than rebar.
Well, rebar's less, I would think.
Well, yeah, rebar's the worst, but you have a number 4 every
2 feet or
2 feet or something.
Yeah.
We're looking at the area. Obviously, thermally, outside's best. But then you have to protect it, and it's kind of a mess.
Homeowner can always trim it off with a string trimmer.
Yeah, and they beat it up with a string trimmer. That's why I read like ICFs, you know, you have to treat them you have to parge them and, you know, put some covering on them. Yeah, it's building science, and the slab edge insulation is trying to do the best we can. We will the code allows the rebar to penetrate it. With the rebar every 2 feet, it still performs much, much better than if you did not have it insulated. I agree completely with what you're saying. Because, yeah, if you don't rebar it, you know what's gonna happen. It's gonna settle. It's fill. Yeah, that's a great question, thanks. Why did I throw this picture in? Some of you have seen this picture because I put it in before. And Morgan and Jessica, my neighbors, probably, I owe them a royalty on this because that's their house across the street from me. What are the little melded spots on the roof? From what? The boot, right? If you were to go in there, on either side of this window, there's a 4x10 or a 4x12 supply air. And the boot has flex duct coming to it, right? But it's close to the eave where there's hardly any room for insulation. And so we have heat. And it's a lot more heat than we have just because of the thin insulation. They are not, as far as I know, they are not one of the ones that's having ice dam problems, but their neighbor right next to them and then a couple more down is. Not only is this an energy waste, does it contribute to an ice damming problem? Absolutely, doesn't it? If it's cold outside and this is frozen right down at the eave because it's just under the soffit, above the soffit, and we build up ice there, and this melts it and just feeds it down and keeps building up the ice, what's going to happen? It backs up under the shingles, and there we go.
Well, even that OSB sheathing or plywood on the inside there is gonna have water condensing or freezing, because that just goes on and off, and you'd be rotting
Yeah.
that plywood out, so.
Yeah, we have the condensation issues, we have everything else. High heel trusses, but the real thing is, I don't know if my friend Jason from down in St. George is online, but he called me up and he had a HVAC contractor on the phone, and I was getting so frustrated with the guy because he was arguing with me that he only had to insulate the round pipe and the rectangular duct, that all of the other components of the duct system, like the return boxes, and he put the little J boxes, you know, kind of you ever seen, I think they were square boxes, but he'd run a 12-inch across the attic, and then he'd take 5 6s off it. And he didn't want to insulate them. And he was trying to argue that the code didn't make him insulate those, they only made him insulate the round pipe. Anyway, down there it's heat gain, huge heat gain. Here it's heat loss. And our duct insulation requirement is already ridiculously low anyway. Here comes another soapbox. If you're in St. George, what's the temperature in the attic in the middle of the summer? I haven't measured 180, but I've measured 160. What's the temperature inside the duct with the air conditioner running, if everything's working fine? 50, 55, right? What two factors determine heat flow? Delta T, the temperature difference, and what's the second one? R value, or U factor. Whatever you have that stops heat flow. So we have let's just for discussion, let's say in St. George, we have 150-degree attic. We'll be conservative. We're 150 in the attic, we're 75 in the house, and we have R38 or R49 trying to stop heat transfer with a 75-degree temperature difference, right? With R38 or R49. We have a duct up there in the attic, and what's our delta T? Yeah, it's 100 or 105 degrees, it's not 75 degrees. And what's our insulation? R8, except for this guy that doesn't want to have any on his boxers or doesn't want to have any on his boots. What's our value of sheet metal? It's about the same as rebar, right? 0. Huge U factor. So we have a lot of heat transfer. The solution is not R24 duct or R49 duct. What's the solution? Get it out of the attic. And if you have to put it in the attic, I know it costs money, encapsulate it and bury it in the insulation.
Brett, the other thing on, our homes are tight enough now, our windows are.
We ought to just put a mic on you, Jeff.
The other thing is, our homes are tight enough now, our windows seal off well enough. Those vents don't have to be out by the windows anymore. They just have to be in the room.
That's right.
And that air's gonna move. You get, especially if you get a supply and a return in there. Or a
Yep.
good pathway for return. I was
Yep.
on a big home yesterday. I won't tell you what city it was in, but the return, the main floor had the return in the basement. There were no returns on the main floor. The air had to go all the way, and it was a big home, to the basement. And the upstairs, I mean, the returns were pitiful on this thing, but that's another subject about returns. I kept telling my, I said, so, there's women, what if somebody farts in this bedroom and closes the door? You can come back in there 2 days later and you're still gonna smell it. There's nothing moving air in this thing. And they said, well, anyway. But the vents don't have to be cleared out over the windows like we always used to put them. And a lot of real tight Energy Star homes, they're just put a vent in the room. And it shortens all the ductwork up, less chance of leakage.
Well, any HVAC guy knows that you can, typical register, you can throw 10, 12 feet, right, Ryan? And easy, yeah. It just depends on, you can throw it, and there's nothing wrong. With the way we build a house now, you're exactly right, with throwing it across the room. Absolutely nothing.
Most of the homes
Passive.
most of the homes now are what's called low-loss homes, which is a new category that ACA come out with 3 years ago. It used to always be, a ton of air conditioning for 400 square foot a home. We're not doing that anymore. Low-loss home is 1,500 square foot per ton, and I'm doing that day in, day out. You need a lot less energy, you need more air than what the Manual J requires, but you're doing 1,500 square foot per home or per ton almost every day on every home, even with big glass walls or whatever. The construction science is just a lot tighter.
Yeah. Well, that home I built in '94, I was conditioning 6,000 square feet with how many tons do you think? 4. Now, it would have complied with the 21 code. I sprayed foam in the 2x6 before we blew in the 2x6. I did slab edge insulation. I did HRV. I did low E glass. And actually, that home, I moved from it into the home I'm in now, which I have improved a lot, but my utilities were always less with that home because it was so well built. Any other questions? The discussion's great. Appreciate it. I didn't want to have to go through this formal set of slides and not have any input from you. This was brought up earlier, and you might have brought it up, Jeff, because you look at this with Energy Star. How many times does it say in the IRC manufacturer's installation instructions? Anybody have an idea? think I counted it, and that was 137 times. In all the I codes, I think it approaches 1,000 times. Why does the code refer to manufacturer's installation instructions? You can't put everything in the code for every single piece of equipment. So the manufacturer, when they build a piece of equipment and they have it listed, they do the testing and listing, they base it on a specific installation procedure. And so the code refers to manufacturer's installation instructions. Manufacturer's installation instructions are part of the code. Just like Manual J is part of the code. It's like, what's the concrete standard, 318, is part of the building code. You know, these are all reference standards that are referenced in the code. They're part of the code. The manufacturer's installation instructions for bat insulation is different than we see installed. And why is it installed wrong? How many code officials? Let's be brave. I know a bunch of them that aren't raising their hands. Jason's raising his hand. Because we let them install it wrong. When I was working for Salt Lake City, and this was in 2005, I went out on a house that they had insulated. They hadn't even attempted to cut around a box. They just shoved it in all over the place, and I failed the inspection. And the builder called me freaked out of his mind that I would fail an insulation inspection. No one fails an insulation inspection. I wanted to say, well, it's your lucky day, dude, but I didn't. But you can see that stuff with a thermal camera. That it's just horrible how bad it is and how much heat loss and heat gain we have through that crappy insulation installation. The manufacturer says that you have to cut and fit around wires, pipes, boxes, etc. You need to split it for wires. You don't tuck it underneath there. It needs to be cut and fit in back around the box. I've had a lot of insulators say that, well, if you're going to make me do it like that, it's probably just as cheap for you to do what? Do a bib system. And guess what? It is a better system. They can get R24 in a 2x6 wall with a bib system. And it fills up all those little spaces that we miss. Surface water heating, and we're almost getting to where we're just going to talk about the sheets that we prepared. If you have, and I know this gets missed so much, and we need to pay a little bit better attention. Lots of times these are not put on the plans, but if they have a recirc pump on a water heater, the energy code requires the loop to be insulated. Why? Because anytime that pump's running, it's just a radiant heater around there. Insulate the loop. You don't have to insulate little branches. The pump has to have a timer. This pump's installed wrong, actually, but that's beside the point. But that is a good insulation system behind there, right? Hot water pipe insulation. How many of us, myself included, ever enforced that? That says, if it's 3/4 inch or larger hot water line, it needs to be insulated. Now, I'm not saying to code officials, go out and hit everybody over the head. But at plan review, if you choose that you're going to enforce this, and we ought to be working towards that, we should be bringing it up at plan review. The code says, energy code says that anything greater than or equal to 3/4 inch nominal pipe is supposed to have insulation on it. Commercial, it's no big deal. We just insulate all the hot water lines. If it's serving more than one dwelling, could that apply nowadays with all the ADUs that we're putting in? The accessory dwelling units? Of course, located outside the conditioned space, from a water heater to a manifold. Located under the floor slab is crossed out. Why? State amendment. Builders in Washington County says, oh, that costs us too much. It's too time consuming. How long does a piece of PEX running in the ground from a water heater room in St. George to the kitchen sink or to the bathrooms, how long does it maintain hot water in the pipe after you stop the flow when it's in the ground? A minute? The ground sucks the heat away. Much greater rate. I think it's 6 times or 7 times what it does in air. That's why we use ground source heat pumps. Do what? They put pipe in the ground to suck the heat out of the ground because there's good heat transfer. Anyway, that's on my list there. So, we're gonna finish up before noon, I think. So, if you're okay, we're not gonna take a break. We'll just burn through this and be done. You have this sheet. Jeff, can I borrow yours? I just want to compliment you guys for registering and showing up. Last class I did, I printed less than the number registered by like 7, and I think I took and recycled 20 handouts, and I printed exactly how many were registered, and we ran out. So I guess that's a good thing. So if we look at this sheet, I don't need it, Jeff. I've got it right here. My key definitions: R value, thermal resistance, higher number means less heat conducted through the assemblies. U factor, thermal transmittance. So that rebar, and I ought to look it up so I know next time, or that piece of duct has a high U because it really transfers heat well. It's probably 4 or 5 or 6 or 10, I don't know, but it's a high number. If you take the U, let's say we know the U of a square foot of that wall. And let's say the U is, well, if that was an R10 wall altogether, then the U is going to be 1 divided by 10. The U is going to be 0.1, okay? So we have a 0.1 U on that wall. And we have 1 square foot. If I take 1 for 1 square feet times the U, 0.1, what do we get? 0.1. 0.1 BTUs will go through that square foot every hour. If we have 10 square feet, then it's 10 times that, right? So a large U, say the U is 10, and we have 1 square foot. Then we have 10 BTUs going through that 1 square foot. So the higher the U, the more BTUs are going to flow through the wall. Times the delta T. So it's U times delta T is the amount of BTUs that go through 1 square foot. Thanks for catching me, Ryan. I knew what I was trying to say, I just wasn't saying it. It's that simple. U times delta T, that's how much heat goes through a square foot. That's why that thing in the attic is so stupid, because the delta T is so high, and if we don't insulate it, we have so many BTUs. That St. George home that does have R8 duct, roughly 40% of the cooling capacity goes to what? Overcoming heat gain from the attic. So if you have a $500 bill in the summertime down there, if you got the duct out of the attic, it'd probably drop $200.
One more thing, most energy efficient homes I've ever built have all had cold roof. How come they're not, addressing more cold roof systems?
We address it in building science. The code hasn't got to where we said high heel trusses are mandatory yet. Cold roof,
Eliminates ice dam, you know.
it completely. Yeah, but it costs money. What do you, I agree. You know what a cold roof is?
Well, my question for him is, is he referring to a cold roof as a spray foam roof deck, or
No,
an actual roof frames on top of a roof?
Trusses where you've got insulation, making sure that you've got ventilation that goes from the outside where your soffits are through to the ridge of the house.
So your ventilation is all above the roof sheeting?
Right.
Yeah, that's,
So
okay.
the entire roof stays an equal temperature.
Yeah,
Some people refer to cold roofs as what are actually hot roofs, where you spray foam the bottom side
We'll
of the
do a,
deck.
we'll do a build-up roof
Yeah.
on top of a, say, you know,
I'll repeat
a
it.
two-by vaulted ceiling.
I agree completely. The whole discussion for those online is, you know, what are we really calling a cold roof? You know, are we spraying foam on the underside of the roof sheathing? That's really not the cold roof as I understand it. What you're saying is a cold roof where we have ventilation coming in through the soffit on top of the insulation and then going out through the top. And it's a great roof system. In fact, I've seen some people doing this with truss roofs. They go in and they put the trusses on, sheathe it and everything, then they come in and put 4 or 6 or 8 inches of polyiso on top of it, sleeper on it with 2x, and resheathe it and vent it at the bottom so you have an 1.5 inch airspace running up through it all. And the shingles and the roofing never sees any of the heat from inside coming up through it. And they did it in Park City quite a bit years ago. We got all the way, raise your hand higher.
Yeah, I go from Park City area, been up there for about 10 years, and we build high-income townhomes. Even as well as we do the ice and water, still do all the roofing, I'm still getting ice dams. Anyway, my next phase, I'm just built a cold roof, where full trusses, sheet with 7/16, put synthetic underlayment down, then 2x2 sleepers, and 5/8 roof decking, and then my roof goes on top of that. So and I use 12-inch heels all around. So it's very expensive, but these are high-end stuff, but I can't deal with the ice dams anymore.
Yeah.
So, but yeah, you get that continuous venting. You've got a soffit that vents your attic, plus you have a soffit that vents the 1.5 inch air gap. And I do spray foam truss ends, I do R50 in the attics, the whole bit, but anyway, this better be a solution for us.
Yeah. Well, hopefully you'll be able to figure out how much you'll save by not having to heat tape everything.
Yeah, that's the thing, we've been putting heat tape, but even the heat cables, the ISO, it melts a little track, but I've had cases where there's 4 feet of snow up there this winter, and the whole thing just slides right off the roof, pulls all the heat cable with it, and unplugs it, and it's sitting on the ground.
Yeah. Yeah, heat cable is a kind of a Band-Aid for ice dams. And like you say, you get all that snow shifting, it tears it off. I've seen lots of roofs that you can see where it's ripped out all the heat tape and everything. And what does it cost to operate that?
Yeah, that's the homeowners, but our market, a lot of them are second homeowners, they're not there, they don't run it, it's up to them, they get mad at me, they get ice dam.
Yeah, you want it gone.
I think that snow up there is insulation.
Yeah, kind of insulation, isn't it? But it's heavy, isn't it? Okay. We've talked about, so this is the start of our sheet. Like I say, first draft. I tried to identify in red anything that was an amendment. We've talked about the R value. We've talked about the U factor. Continuous insulation we talked a little bit about before. Continuous insulation is great. In fact, come to Marc La Liberté talking in June.
June 13th and 14th.
In fact, Construction Instruction, it's an app. You can download it on your phone, it's free. He has a calculator on there that you can take your frame wall, you can put what your cavity insulation is, you can put what your insulation is that you're putting on the exterior of a wall, so you're putting some foam on the outside, and you can run different scenarios. And one of the scenarios I've ran before is take a 2x6 wall and spray that 2x6 wall full of polyurethane foam. Now that's going to cost you, so 5.5 inches, so you're $5.50 per square foot to spray that. That's pretty expensive, isn't it? And in that 2x6 wall, you're getting, I can't remember the number exactly, but you're going to get a 34, something like that. I was saying 30 something for the, well, you get 34 for the foam.
Yeah, close up.
But what does the thermal bridging do to you? The studs. And that's what his calculator tells you. I think it takes you down in the 23, 24, something like that. And then you can take that same 2x6 wall, put R24 in it with a bib system, and put R5 or R10 on the outside and have a cheaper wall, and it performed much better. So it's cool. It's constructioninstruction.com. They have an app. You can download it on your phone, go to that wall calculator, and it's really interesting. I think you'll really enjoy the eye-opener that you get from that. There's a lot of places up in Canada and Alaska now that they're simply moving to no cavity insulation. They're just putting it all on the outside, continuous insulation. We talked about the county line thing at Snowbird. So I just summarized a lot of the stuff we just talked about. Question?
Was a question, just a comment, and that is, I have been building with insulation concrete form, ICF, and just in 2010, I built a new home for my son, and this, we're on a hillside. We had 2,500 square feet on each floor, and after he had lived there for a while, he came to me and said, "Dad, if the gas was off and the power was off, I'd stay in the house and I'd never take any hurt." He says, "I may put on a jacket." And then a few months later, he said, "Dad, something must be wrong with my house. Here's my gas bill for November. It's $20. I'm a believer in ICF.
I am too. Why is ICF so great?
Continuous insulation.
Continuous insulation, twice.
And a thermal mass.
Thermal mass,
Performs like an R40, has an R24 R value, performs like an R40.
yeah. What do you have to do with, if you build with ICFs? You have to mechanically ventilate with balanced ventilation.
Heat recovery ventilator.
You have to do a heat recovery or energy recovery ventilator because your building does not leak. How much air leaks through a concrete wall with 2 layers of foam, one on the inside and one on the outside? The only thing that leaks is your doors and windows and your ceiling. That's it. I was involved. I mentioned I do a little bit of expert witness work. I did a case, and I won't say which. It was in this valley. It was some townhomes that were built, and there was probably like 30-something units. One building had like 18 units, one had 12, but anyway, 3 buildings. They were flat roofed with a membrane, and they put little rooftop units on them all. And they chased water leaks around the windows for a year and a half before they realized it wasn't leaks, it was condensation. What happens with condensation if the humidity goes way up in your house? Condensation just, it goes way, way up, the amount of condensation you have. They didn't have mechanical ventilation. It was tight, tight units. they had to put in ERVs. That's what solved the problem. You know, and they were suing everybody. You know, it was the HVAC guy's fault. It was the guy that installed the windows' fault. All these people were at fault. No, they were at fault because the design sucked and it didn't have mechanical ventilation that you had to have because it was so tight. You could not put a fan in there, let it run, and plan on it leaking into the house like we can on most homes built today. Good comment. It is, it's continuous insulation, and it just makes so much difference. So, here's where we get into our options. I've listed, and this is one of the things I want your input on, I've listed our 5 options across here. I've included code references. I've given you a spot that you can make a note or say it complies or it doesn't. And under the envelope, I've identified that we need to, whichever one we use, we need to identify our U factors and all that stuff on the plans. We've beat that one up. On our prescriptive table, here's our code reference. If you're doing plan review, it's per climate zone. You have to equal or better than the table value. If the window says 0.35 as it does on the prescriptive table and they put in 0.32 window, great. It's a better window. Identify them all on the plans. There also is a U factor table that's in the code. We have an R value table that I showed you. There's a U factor table. I rarely ever see that used because if you use it, you have to provide calculations for the wall assembly. You put R38 or 34 in the cavity, you have to account for what the wood is going to conduct through. Second option is res check. I would require a passing signed res check submitted with U factors, R values, solar heat gain coefficients as included on the plans. I have had builders call me and say, hey, my engineer or my architect's from out of state and he did a 2018 res check and the city rejected it. Is it? Huh? It passed. Why would we reject a more stringent code and it passed the more stringent code? Because Utah's on the 2015 res check. Let's not do that. We can exceed the code. We don't need to make them do it on 2015 or 2012. I mean, I have some places think that you have to do the 2012. You don't. You can accept a 18 or a 21. How many have used res check a little bit? A warning to you, I don't know on the residential, but on the commercial, you cannot download the 2021 ComCheck. You have to do it online. You have to do the web check, the web ComCheck. So next time I present something, I'll find out before then. But I think you might have to do it online there too. Third option, the simulated performance. I've only seen this used like 4 or 5 times on homes in the last almost 20 years I've been involved on the code side. I don't know how many you've ever done, Jeff, or none?
Send them over to Mitch.
Yeah. Lori.
So we just got some for some townhomes, but how do you verify what they're basing their values against, like the cost and stuff difference is correct?
I'm going to have you repeat that again. Sorry.
So when they do the simulated performance and they say they're providing their cost analysis per year, how do you verify that that's information is correct that they provided?
We're not looking for that. We're looking that the thermal performance characteristics that they used in their analysis are the same ones that are on the plans. Does that make sense?
Well, because they provide a
They provide-
baseline and then an as proposed. And we make them put the as proposed information on the plans?
We
That's all
don't,
we need to do then?
yeah, we're gonna trust that they, I mean,
Really,
don't-
we're gonna trust them?
Some of the software has the baseline home in there.
yeah. Well, the software generates the baseline home by what you put in, right?
Yeah, and the utilities here, you know, from time to time have come out with one to meet their rebate programs too, a different baseline home that we
Yeah.
use for.
I guess if you question what they submitted, I mean, the first thing I would do is look to see who did it. Because I know this guy, and I know Steve, and I know Mitch, and I know all these other guys. And if their name's on it, it's like any other, well, it's like special inspectors, and it's like, people that are providing metal trusses on your commercial buildings. We approved those people, and some are trustworthy. If you have a real problem with it, then maybe it needs to be peer reviewed, but, if you have a question on one, shoot it to me, and I'll take a peek at it and give you an opinion. Okay? Good question. I don't think you're gonna see this. You're gonna see more of this. And,
Difference, because it says typically performed by HERS rater on the simulated performance, so that it's not.
this is too.
Yeah, so what's,
Yeah.
when you're saying you've only seen it once, you've seen it multiple times. So that-
I've seen more of this than this. I see simulated performance on commercial buildings all the time.
Okay, so there's different versions of HERS? There's a
Well, it's not HERS that they use on commercial buildings. It's different. Commercial buildings, how do they think they build a building with all that glass? They have to trade it off with mechanical systems and lighting systems and all that stuff. But it's getting really hard in 21. If you weren't to that class, I mean, it's, the 21 that we did adopt for commercial buildings, it's a little more challenging. So anyway, these two options, this one is the one I think we're gonna see more of. We know about the score now. And then the fifth option, we've kind of beat that one up. Allows the equipment trade-off. It's there for you builders. You can build a budget home, and it's gonna be 5 to 10% poorer in performance than one that you use the other paths. Yeah, this is, I mean, you're gonna use it, it's available, but, when I showed you that picture of my neighbor's home, when that was built 8 or so years ago, I had several of them come up and say, is this a really efficient home? And I says, well, it meets the minimum requirements of the code. And say it was a POS, but yeah, it's one of these.
Remember, the code is the absolute worst thing you can do to a house by law.
You hear what he said? The code is the absolutely worst thing that you can do by law. And what have I spent most of the day talking about? We're not even doing the worst thing. We're doing worse than the worst. Too much.
We're outlaws.
So anyway, I welcome your input on that chart. The first thing, verify, have they picked a compliance path?
Sorry, on the 2012 Utah Res check, multifamily, do you input per unit or building as a whole?
I've heard both. And when you say multifamily, is it townhome or is it?
Well, correct me if I'm wrong, if it's over 3 stories, it's considered commercial, is that
You're-
correct?
yep.
And it would fall under the COB check?
Yep, exactly. But the thing is, I'm trying to remember if Res Check allows you to do multi.
It does.
It does, doesn't it?
So it has 2 tabs on it, one is for single and 1 and 2 attached, and then multifamily. So if it's anything bigger than a duplex, like a townhome, where you've got multiple units, 3 or 4 units, it's multifamily, and it doesn't allow you to run at anything but the UA trade-off. You can't do a performance alternative.
Right,
In my understanding, it's the shell, not individual units.
right, yeah. So it's just an envelope. That's all. It doesn't, like he says, it doesn't allow you the options. You can never use the equipment trade-off because you can't do a res check with more than one piece of equipment, one system. Res check doesn't let you do two systems. Now, I've accepted it before if both systems were the same. Both were 96% efficient, both were 14 SEER air conditioners and stuff. But technically, res check does not allow you to do two systems. Yeah, or use the worst one. Construction documents, I think we've gone through it all. The red is what the current 2015 code says, not what the latest amendment says. I have code sections on there. Construction documents include all the documentation required to be submitted in order to issue a building permit. That's kind of for the building official to choose, even though their ability to choose that is disappearing. And I think that's why you're seeing a checklist now, is because they don't want the building official to be able to make a list. Will?
Brent, is the red language there a reference to State Code Section 10.6.160, at least for municipalities?
That's an amendment to the code section I have listed there. And I have a sheet, I actually have a sheet of the pages that have amendments. If you send me an email, I can send it to you. It might not be completely 100% updated because we had a few minor changes in 21. Air leakage. This is the, we're not going to get out early because this is the big one. The code without amendment says you'll blower door test every house. You will use the inspection checklist on every house, and if you follow the inspection checklist, you will pass the blower door test, basically. And it goes through, you have to install the insulation and everything perfectly, and it has, if you're tighter than 5, you have to mechanically ventilate. And for our climate zones in Utah, we all have, in the unamended code, a requirement for the blower door test that is below that 5. So what I'm saying is if we did not amend the code, every house has to test tighter than 5, and tighter than 5 has to mechanically ventilate. So if we did not have, going back to 2015, if we did not have these amendments, every house we built would be blower door tested, and every house we built would have mechanical ventilation, period. If you complied with the code, that was part of it. The amendments that came out, and they go back into 12, but into 15, is you could either blower door test or you can do this inspection checklist. And so people say, well, we'll do the inspection checklist, and then everybody forgets about it, and you build the house and nothing happens. And we don't know if it's tight or not. Maybe it is real tight. We didn't blower door test it, so we cannot trigger mechanical ventilation. Some builders have said, no, I'm going to test it because I don't want to do some of the things on the checklist. This is the one that we probably are the least compliant with of just about anything that's done out there.
Some building officials are actually required it to be blower door because they're concerned that it is going to be below 3.
Yeah. Some building officials are requiring it, and they're kind of walking a fine line. Most builders, I don't think, are opposing them very much on it. They're kind of protecting themselves because if it's tight, they mechanically ventilate. In fact, a lot of those that are blower door testing by choice are typically mechanically ventilating anyway. Just put in the fan, set it so it runs all the time.
We're talking a bath fan, so everybody realizes.
Yeah, it's a bath fan. Has anybody have a, do you have a comment, Jason?
Can the fan be on a timer?
Jason says, can the fan be on the timer? Go to the IRC, it'll let you put it on a timer, but it has to run at least 1 hour every 4 hours at 4 times the rate.
Yeah.
Does that make sense?
It's based on ASHRAE 62.2, the amount of ventilation. You've got to boost it way up.
Let's say, Jason, that you have to have 50 CFM of continuous ventilation. You only want to run a fan for 1 hour every 4 hours. That 1 hour every 4 hours, you have to exhaust 200 CFM. So you equal the same amount of exhaust air during the day, throughout the 24-hour day. Does anybody have a Panasonic or a similar fan in their house? Can you hear it?
You know, I mean, I put Panasonic fans in the stuff we built for 10 years.
Yeah.
So they're wired that when you turn the switch off, it automatically just drops.
To low.
And, you can't even hear it, it runs 24/7. And then when the homeowner goes in, they turn it up, it goes up to 80 CFM. Use the bathroom, turn it off, they already know it's off.
Yeah. And it has timers built in it. You know, the one I put in, I just put a momentary switch on it. You touch the switch, and it goes to high speed, and I program if I want it to run for 10 minutes, 20 minutes, or 30 minutes when you hit it. And you can't hear it.
And you just only need to do one in the house somewhere.
Yeah, put one in the house someplace. It's a central exhaust. It draws in through the leaks. You can't do it on ICF because ICF won't leak enough, but everything else virtually it works on. And it's your cheapest, best form of mechanical ventilation. You should just do it.
You can just say, well, it paints streaks and stuff in the master bath, because we all do. We take our shower in the morning, get all that steam going in the bathroom. We walk out, we turn off the light, we turn off the fan, we go to work. That's where all that steam starts condensing on the ceiling, running down the walls, streaking your paint.
Yeah.
And creating mold issues on the backside of the drywall.
The one I put in, I bought a humidity sensor with it too.
Yeah.
So it runs until it clears the humidity.
And the setting on there on the timer, if I'm not mistaken, you set that timer, you set for 10, 15, 20 minutes, wherever you set it. When you turn the switch off, that fan will continue running at high speed for that many minutes and then drop down to the low speed, so it gets time to exhaust all that moisture out of the room.
Or odors. It's just,
Yeah.
they're really slick. When I bought it, I put my amp probe on it. I couldn't get a reading. It draws about, I mean, you look at the specs on low speed, it draws about what a doorbell transformer draws.
They're a DC motor.
They're a DC, ECM motor. They cost you, bare entry level is gonna cost you $100, you know. With all the bells and whistles I put on mine, I think I was in at 2.5 or something like that.
But you also need to ventilate it right. Without any P-traps in the vent, things like that.
Yep, yeah, built. So anyway, any other questions? We do have a question?
Something's just now confusing me. So in the red, it's saying on air leakage, you got SFD must be a maximum of 3.5 ACH. Townhouses, multifamily, 3 stories or less, 5 ACH. Smaller ACH, inside tighter home, if testing, bold letter, testing at 3 ACH or lower, is that for both the single family and the townhouse 3? So I'm really confused on how those numbering is written.
Yes.
So the numbers are,
The whole.
it is
How
confusing.
it's established, what I see is, if a single family is built the same size as that duplex, just copied over, or the townhouse is the same size as single family, why not have it all just 3.5?
You can't get it.
You remember the Beatles song?
Yeah, you gotta have it.
Jeff makes a good point. Multifamily is tough because what do we do on a single-family dwelling? We wrap it in Tyvek or something, right?
Okay.
What do we do on a multifamily? We have those party walls, those common walls. And unless they do something to seal those, or they do aero barrier, we have leakage between units.
Okay.
And that's the reason we stayed at 5.
All the way to the attic.
And they draft to the attic and everything. Yeah, it would be a change in construction, and there's ways to do it, but currently, they're not getting built that way. So that's why, you know, we used to be at 5 for the single family too. And when it came around that we were dropping, they said, wait, and we were supposed to drop to 3. And the legislature says, oh, we'll drop single family to 3.5, and we're gonna keep townhomes at 5. And it's probably not a bad thing, other than the leakage between units is also the leakage that transfers odors and everything between units.
So that number basically comes down to up on the hill then? Thank you.
Okay.
I think more of that leakage is up at the top.
Yep. Yeah, in fact, someone, and maybe it was Mark, with construction instruction, he said if you had those multifamilies, if you picture framed, up the perimeter, that's that dividing wall, that common wall, we got an airspace between there. If we sealed around it like a picture frame, we stop it going up, we stop it coming out. And that would.
Can you spray foam as a fire issue with it,
Yeah.
I mean, but they say, well, I stuffed rock wool in there. Well, fine, you can put rock wool up in your mouth and you can breathe through it, so that didn't
Yeah,
do anything.
yeah.
That's to slow a fire down.
Has to be air permeable. Air impermeable to do the air sealing.
Thank you.
Good question. So anyway, we have these two options. We're missing the boat on a lot of stuff. In fact, what we're missing the boat on is we're just not doing it. We're, across the board, probably 20, 30% of the jurisdictions are trying to do something with this, and some are doing nothing with it. Recessed lights are supposed to be gasketed and sealed and all that. If you have registers coming out of your ceiling, like my neighbors and everything, they're supposed to be caulked and sealed or taped. Ducts outside the thermal envelope, if it's in the attic, it has to be R8. If it's in a crawl space, R6. R6 is okay in the attic for 3-inch and smaller ducts. So if you have one of those high-velocity systems, that can be R6, but hopefully they're burying it in the insulation. If you have a chance and you're a builder, go to the 18 and the 21 code and look at what they're talking about for encapsulating ducts. If you have to have ducts in your attic, let's make an effort to get it down in the insulation. Any jurisdiction out there that's listening to this, please do not make them hang their duct up out of the insulation. I know the theory is, well, I don't want to lose that R38, the value of all the R38, but what you're doing is you're exposing the whole circumference of that R8 flex duct to 150 or 160 degree air. At least if it's down in the insulation and just a little bit of the top's exposed, we don't have near the heat gain that we do otherwise.
That's hot here in the valley too, because we have asphalt shingles. St. George, they don't, asphalt doesn't melt off the roof, but
I had my roof replaced a year ago, and when they did it, I had them add some extra attic ventilation. Before I had my roof done, I measured 147 in mine. And I face north and south. I don't have a west-facing flat roof system. Yeah, I face north is what I face, and yeah, I've hated this winter because, anybody have a north-facing house?
lovely driveway melt off.
Yeah, the driveway wonderful, and the front porch, and the sidewalk, and the steps. My wife says before I get any older, I need to put snow melt in. Duct sealing. If you have at least 20% of your duct outside the thermal envelope, it has to be tested. And Jeff talked about that. We pressure test the duct system.
Measured by lineal footage.
Yeah, it's lineal foot of duct length. If multiple systems, if it's a 2-story house with 2 systems, and the one upper system is in the attic, just count that system. Don't make them test the main floor system that's all inside the envelope. R3 insulation on that pipe loop. R3 insulation, we talked about that when we went through that. 3/4 or greater, and I just kind of listed those things. So as you're going down the plan review, you just kind of look at those things. The plumbing code requires in most cases now that you bring 1 inch into the water heater. When we hit the water heater, we might drop to 3/4, but out of the water heater, we should still be insulating that. Mechanical ventilation, we've just talked about that. The blower door testing and the triggers for mechanical ventilation. Continuing from the other, man. One thing I need to add, and it's in red text there, we actually in 2019 session, I think it was, the legislature did adopt the tables out of the 2018 res check that says if you put one of those fans in for mechanical ventilation, it needs to be what we call a high efficacy fan. It has to have the DC motor in it. You can't put in, well, if you put in a $13 fan that you get from Home Depot and let it run all the time, before you went crazy, it would probably fail, right? Because they're so noisy and they're cheap and they draw a lot of power. So you can't use a cheap fan for mechanical ventilation.
What I'm seeing accepted, Brent, is sometimes they'll fill the blower door, the inspector will, 99% of the time, the inspector doesn't even really notice that below 3 thing. And so if the builders, if they do, the builder will go in there and have the electrician take the light switch out, hardwire the fan on, put a cover plate on it. Now that fan's running continuous until the inspection's over, and they put the switch back in, but that's another story. And they're noisy as could be, and they usually don't even get air to the outside of the house.
Yeah. Yeah, I could do an hour on bath fans and flex duct and everything. Couple other things that as you're going down through the list on a plan review, we could do a whole 5 days on manual JDNS, and so we're gonna skip through that right now. We could do duct system 2, snow melt systems. So many people say, why are we worrying about energy when we have snow melt systems? Well, the code has picked up, if you put in a snow melt system, it has to have an automatic control on it. You cannot have it manually operated. It has to have a sensor, and you've seen them in the driveways and stuff like that. If there's no moisture, it doesn't run. If the temperature of the pavement is greater than 50 degrees, it doesn't run. If the ambient temperature is greater than 40 degrees, it doesn't run, period. And that's how those TechMark controls work, and they work well. So yeah, they use a lot of energy, but with the right control, they only use what they have to. Pool heaters, you have to have a ready access switch, timers for the pumps and heaters, and vapor retarder covers for all the pools. If the pool's heated, and there's some exceptions for if you're heating it with waste heat or if you're heating it with PV or, well, not PV, but with thermal solar. And 75% of the permanent light fixtures have to have high efficacy lamps. That one solved itself. You know, when we first started talking energy code, CFL was what was available. LED was so expensive that no one could afford it. It solved itself. Well, we buy LED lights, we have all the color and everything else. That is it. I really appreciate your questions. It really makes it better. Please send your brilliant ideas on how we can improve that sheet. I know I won't hear from too many of you, but if you have just a single comment, yeah, it's great, but I wish you would do this, you know, please feel free to do that. And I'm sure we'll be discussing this again, and we'll probably be posting something or sharing something by email. Thanks again, and hope to see you again.
Yes, Thank you again for coming. If you have any questions about Brent's presentation today or you want to review, it will be on our YouTube channel that we did live stream today, so you're more than welcome to check that out. Any blogs that Dr. Energy has written, Brent has written, will be on the Utah Energy Code website. So if you have any questions, they might already be in a blog format, and you're more welcome to check that out. May 11th, we will be doing another Brunch and Learn here, which will be a quick reference to the commercial code for 2021. May 23rd, we will be doing a field training and featuring AeroSeal and Aero Barrier, where we will go over duct sealing. So there will be that available. And June 13th and 14th, we will be welcoming construction instruction here. First day will be a classroom. Second day will be an on-site training, still to be determined on location for that one. But if you would like to subscribe and get our emails and know when these classes are available, please go to the website. And we would like to thank all of our sponsors today. Rocky Mountain Power with their Watt Smart Business program, Thermwise Energy, or Thermwise program with Dominion Energy, and their new construction programs, and of course, the Utah Office of Energy Development and the DOE for helping us with these classes today. Thank you very much and have a great day, you guys.